monthly temperature since 1916 for Spain. Let's start with an introduction. We have recently created and published gridded data sets of monthly temperature for Spain with a spatial resolution of 1 kilometer, covering the period 1961 to 2018. You can see here on the left the cover of the publication, and in the bottom you have a link to the publication. I'm sorry because it's only in Spanish, but you can check it if you want. These data sets are continuously updated. Every month we create the new provisional temperature grids, and 6 months later we create definitive grids when we have all the data from our network. And we have also used these gridded data sets to create a new temperature reference series for the whole of the country to replace the previous reference series that were based on a set of 42 stations. One of the advantages of using grids for reference series is that it's easier to go back in time, because we don't have the problem of the missing values, the gaps in the series. And now we are trying to extend this reference series back in time as long as possible. And at present we have generated monthly temperature grids of the mainland Spain since 1916. So in this presentation, I'm going to show you the methodology that we have been used for creating the grids, and I'll show some products that we have obtained from the gridded datasets. Regarding the methodology, we have defined two study areas. The first one is here. It comprises the mainland Spain, the Balearic Islands, and Ceuta and Melilla cities. These are Spanish cities located in the northern coast of Morocco. So from now on, I will refer to this area as mainland Spain area. I hope that my colleague José Antonio Guijarro doesn't feel annoyed for that, because he lives in the Canary Islands, in the Balearic Islands, sorry. And the second area is here in the bottom. It comprises the Canary Islands. Regarding the data, we have considered 3 variables: monthly mean daily maximum temperature, monthly mean daily minimum temperature, and the monthly mean temperature. The monthly mean temperature is derived from the grids created for the maximum and the minimum temperature. And we have to say that the station data have not been homogenized before the spatial interpolation. So we think that the resulting grids are not suitable for studying the climate variability in specific points. But we think that they are useful for climate monitoring in big areas or the whole country. Because in bigger areas, the inconsistencies of the data frequently cancel out each other up to a certain point. For the selection of the study period, when we try to go back in time as far as possible, we consider 2 aspects. First, the minimum number of data for obtaining good quality temperature grids. We estimate that we need about 100 of the stations in mainland Spain and about 20 stations in the Canary Islands. So here we can see on the left the graph of the number of stations with monthly temperature data from the mainland Spain area. And we can see that we have few data in the 19th century, and only after 1910, 1911 or 1912, we start to have more than 100 of stations. After that, the number of stations increases for several decades, except in this small period that corresponds to the Spanish Civil War. And we have more than 500 of stations after 1955, and more than 1,000 of stations after 1970. So we have enough stations after the 1911, 12, more or less. In the case of the Canary Islands, on the graph on the right, we see that we have less than 10 stations up until 1945, and only after 1961 we have more than 20 stations. So here this area it's more tricky for spatial interpolation. And on the other hand, we have considered data quality, because the historical old data have a lot of problems, as we all know. And one of that problems is that in Spain, as in many countries, we used open shelters during the 19th century and the first years of the 20th century, before the Stevenson screen became standard. And some studies have been carried out, like the screen project that you probably know, to compare the data temperature registered in both types of the screen. Here in the picture, we can see on the left a Montsouris screen replica. It's an open screen used in Spain, and I think it was also used in France. And on the left, we can see two Stevenson screens. So in this project, the temperatures registered in both type of screens were compared, and the conclusions were that the maximum daily temperature was considerably overestimated, whereas the minimum temperature was underestimated. And we know that in Spain, the old pre-Stevenson screens were not substituted in some main stations until the mid of the 1910 decade. So finally, we choose 1916 as the starting date for the study period in the mainland Spain area. You can see here in the red color the beginning of this period, because we have more than 100 of stations, and main stations have replaced the old open stands in that date. In the case of the Canary Islands, as I have said, the study was not finally sent back in time due to the low density of the stations, because we have few stations before the 60s. And it's a very tricky area because we have 7 small islands. They are isolated, and it's a very rough terrain because they are volcanic islands, and they have big mountains in many of the islands. So there are very different climates in the north and in the south of the islands. So we need a really dense network to obtain good quality grids. Maybe in the near future we could try to interpolate data since maybe 1946, but not for the moment. Regarding the data quality control, in our climate database, we apply several data quality control procedures, but as these processes have evolved over time, we can find in the historical temperature series anomalous data that have not undergone the present quality control procedures. So we have applied an additional automatic validation process before the interpolation to test the spatial consistency of the data, so that every temperature data is compared to the estimated value obtained in that point by interpolating the neighborhood data using the same method that we will use in the final interpolation. And those data that differ more than 3 standard deviations, the residuals differ more than 3 standard deviations, are rejected. So we can see here in the graph the percentage of monthly temperature data discarded in the automatic validation process. And we conclude that the automatic control process works properly in the second half of the period. We can see here after 1950, approximately, the percentage of monthly temperatures begins to decrease, and it steadily decreases until the end of the period, which is a good behavior, we think. And we see that in the first decades there is a more erratic behavior of the percentage, and we think that in these decades, in this period, we don't have a high density of stations, so that data cannot be effectively compared to its neighbor. So it's to be expected a lower quality in the first half of the study period grids. Regarding the grid interpolation, the method that we used for the spatial interpolation was the habitual method in the Spanish meteorological agency for climate interpolation, that is the multiple linear regression with ordinary kriging of the regression residuals, and we use elevation, distance, northing, and distance to the coast as independent variables. And an exponential model were used for the Programa yesterday. And we also carried out leave-one-out cross-validation to evaluate the performance of the spatial interpolation and the accuracy of each grid. So here we can see the trends of the errors for the 3 variables. On the left, mean temperature, on the maximum temperature, and the minimum temperature on the right. And in the dotted lines represents the errors for the automatic quality control process, and in solid lines we have represented the final error. So we can see that the automatic quality control significantly reduced the errors in every case, and we also see that the errors are roughly constant until the 1965, more or less, and after that date, the errors steadily decrease again. So we expect more quality grids in the second half of the study period. And finally, I'm going to show you some results, some products that we have created. First, we can see here some examples of grid data sets. These are examples of April 1916 for mean temperature, mean daily maximum temperature, and mean daily monthly mean daily minimum temperature. We also created annuals grids and 50-year normal temperature grids, as you can see in this samples. And we have used these reader datasets to calculate provincial and national statistics. As you can see here on the left, there is an example of the annual mean temperature for 1992 for statistics for each province. And on the right, monthly average temperature anomaly of June 1992 in each province too. More examples. Of course, we have used the reader datasets to create annual mean temperature anomaly series for the mainland Spain, and we can see here these anomalies relative to the 1961-1990 mean. And more examples, we have also used the reader dataset series for a trend analysis of the annual and seasonal temperature. And we can see here the series and the annual and the trend for the annual mean temperature in the mainland Spain area. The same for the daily maximum and minimum temperature series, and for the seasonal mean temperature series.
You have 2 minutes, Andres.
Okay, thank you. So to end up some conclusions, at present we have high resolution reader datasets of monthly temperature for the mainland Spain area since 1916 and since 1961 for the Canary Islands. The quality of the grids is lower during the first decades of the study period, but it progressively increases, especially after the 60s. And due to local inhomogeneities, we think that these data sets are not suitable for studying the climate variability in specific points, but they can be useful for climate monitoring in big areas or for the whole country. And we have recently replaced the old reference series based on a set of stations and by new reference series based on the grid datasets since 1961. But in the near future, this series will probably be extended back in time until 1960. So that's all. Thank you very much for your attention.
Thank you, Andres. I haven't. Well, there is one question in the chat from Jose. Do you see that?
No, I don't see. One moment, I have to reopen the window. I don't know.
Jose, can you just ask the question in public?
Sorry.
Jose? I can ask it. For the early decades, well, it is bad. For the early decades when data are sparser, have you considered the possibility of using reanalysis data to detect the outliers in the series?
No, we haven't considered it yet because we need to have a series on the fly. We have to just create when a month finishes. We need to have series, so we prefer only use data from the network station.
Okay. Are there any other questions? Just put them in the chat. I have one question because in the early parts you have not that many stations available compared to the last part of the period. Have you considered to reconstruct the recent years just using the number of stations you have in the first part to see if you lose some kind of spatial variability?
To the concern, yes, we have considered it, but we have not started to make to make some text for it. So maybe in the future.
Oh, it's okay. If there are no other further questions or comments, well, you can just ask it in the chat, and Andres can look into it and answer there as well. I thank you for a very nice presentation. I like it very much. And then we proceed to the next presentation, and that is Will Laura from Peru, that will present the actualization of national climate classification maps for Peru. So.
Yes, thank you. Can you hear me?
I hear you clear. So then just start your presentation.
Yeah. One moment, please. So you can see the presentation?
Yes, we can see it.
Yeah, all right. Thank you. So good day, everybody. My name is Will Laura. I'm from Peru. And today I'm going to give you a presentation on the actualization of National Climate Classification Map of Peru. This work was carried out with my colleagues of the National Service of Meteorology and Hydrology of Peru. So this work was one activity of the Climate Change Management Support Project that is funded by the Development Cooperation implemented by South of North Development Institute for Global Change, and comes under the Ministry of Environment and the National Service of Meteorology and Hydrology of Peru. So this work is framed in the component 2 of this project to have a better climate information for decision making. Well, this kind of map, the climate classification, was developed the first map was developed in 1988, and until now was the official map. So the aim of this activity was update this map of climate classification, and then the utility and the reason to update this climate classification is because it's a climate management tool for the field of economic, society, and environmental activities in our country. So this presentation will have 3 parts. The first, I'm going to talk about the climate controller, the input information to run the statistic model. The second part, I will talk about the process and to validate the statistic model to make the spatial interpolation. And the third part, it will be the results and the conclusions of this activity. So the climate controllers of Peru present the variety of climates in Peru is the result of meteorology, oceanic, and continental controllers. For example, in the continental controllers, we have the Andes mountain range that in an interaction with other meteorological systems that exist in the lower, middle, and high troposphere. The climate conditions depends on the zone of Peru. For example, this interaction of the anticyclone, the South Pacific anticyclone with the mountain range influence the subsidence and the dry winds that is a characteristic for the Peruvian coast, with a climate of arid. So the purpose climate classification is because we have to know the variety of climate we have now. So for that reason, the first step is get the meteorological data. For that, as you can see in this map, the red points show the position of each conventional weather station. And as you can see in the map, you can see two characteristics. First, the density of conventional stations in the east part of the country have a low amount, have a low density. And now in the second characteristic is that the red points, we have red points in the neighbor countries like Ecuador, Colombia, Brazil, and Bolivia. So the purpose of this was increase to get more information, meteorological information, to get a better estimation when we run the statistic model. So we count with a total of 504 weather stations in total. And once we got this information, we carry out a quality control and validate, verify the flags, and validate these flags with a spreadsheet of each conventional station. As you can see in the picture. And also, once we get this information meteorological with quality control, we proceed to calculate the monthly climatological normals. For that, we apply a variety of criteria. In part, respect a percentage of missing data. We modify these criteria by the national service that was established by the weather or the World Meteorological Organization. For example, in precipitation, we don't use the information about that certain month that have more than 3 days with no data. In a similar case, for maximum and minimum temperature, if there are more than 5 days consecutive days with no data, we don't use this to calculate the climatological normal. So with this climatological normal, we proceeded to calculate each index of the methodology, the climate classification. We use the methodology of Thornwine, published by 1951, because this map is an updating, an actualization of the first map that they used this methodology, the Thornwine, and consists by 3 indexes. The first is the effective precipitation index that is calculated by using the monthly average of precipitation and temperature. The second is the thermal efficiency index that uses the temperature average. And the third index is the seasonal concentration of moisture. And this index is calculated from the first index of the effective precipitation. So once we get these values, this methodology categorizes these values in a variety of range from, for example, in effective precipitation from very rainy to arid. In the thermal efficiency is from warm to glacial, and the index of seasonal concentration of moisture, it can vary from abundant humidity in all seasons of the year to moisture deficient in all seasons of the year. So once we get these, we calculated these values of each index per each conventional station, we proceeded to validate the statistic interpolation model. We use the multiply linear regression equation that use independent variables like altitude, latitude, longitude, and natural regions to estimate the values of each index. For this, we know that this index is calculated by precipitation and temperature. It's necessary to standardize these estimated values, the dependent values, and for that we use the logarithm. As you can see in the graphics on the left side of the slide, once we apply the logarithm to standardize the behavior, you can see the behavior of the value estimated in the index precipitation, effective precipitation, and in this case, the behavior tends to have a mean to 0, and the linear tendency is better. So to use this statistical model, we first have to prove and validate 5 assumptions. The first assumption was the normativity of error, the second, the homogeneity, the third, the independency, the fourth, no multicollinearity, and 5, the linearity. So once we validate these 5 assumptions, and from a variety of tests, we proceed to calculate a cross-validation of the statistic interpolation model. As you can see in the chart, we calculate the measures to get a sense of how well is our estimated values with the observed values. And we calculated these measures from each month and by each index. Once we get these values, we have the confiability to use this multiply linear regression to make the spatial interpolation. So we apply, once we get this, we calculate this function and the parameters, we apply this function per each pixel of the raster image of the satellite information. And this was calculated per each index, as you can see in the map. And then we apply a technique of map algebra to have the combination of these 3 indexes. And finally, we denominated the preliminary climate classification map. Why? Because we know that we have certain limitations when we are doing this process. Because as you remember, I said that we have less in particle zones of our territory, we have less density of climate of conventional stations. And also we have by the mountain range, the Andes mountain, we have a complexity or complex topography, and the serves maybe in part for the statistic model that we apply, what will be in a less good estimation. So for that reason, we think and develop a last step in this process. That was the validation of the climate classification map, doing workshops via presential and virtual way. And the purpose of these workshops was to convocate many specialists over the country to get their observations, commentary, and supports of the climate classification map. Because we know that these specialists have a lot of experience in their work area. So once we get these observations, we analyze this if with another source of information, for example, life zones and ecosystem, type of ecosystem over the country. So in this workshop was 4 workshops presential and more than 10 virtual workshops. And then we finally get the climate classification map of Peru, as you can see in the right side of the map of the slide. So to summarize this work, I show the entire procedure of this activity. We first introduce the information climate, then we proceed with a quality control. We proceed to calculate the average months, and then we proceed to calculate the values of each index of the Thornwine methodology. Then we calculate and estimate the function of the statistic model. Then we proceeded to calculate it, to estimate the values for the entire country using the technique of map algebra to finally make the validation with the specialists in the entire over all the country to finally get this map classification. So with this map, we get now Peru presents a range of 38 climates spread over the vast national territory with extreme climates such as very humid and warm and all year round, the hot desert and the glacier. The variety of climates are made up of 4 very rainy, 11 rainy, 13 semi-dry, semi-arid, 2 arid, and 1 glacier. This, if we compare with the before map, now we get 10 climates more. And that is all for this presentation. Thank you for your time.
Thank you, Will. Are there any questions? Yes. There is one. If you can share the web page where your final climate classification map and results are available for the public, you can add that into the chat, for example. Have the possibility to do that. Are there any?
Okay. I was close the presentation.
Yep, that's okay.
Can you repeat the question, please?
There was more a comment. If you can share the web page where you have your final climate classification map and the results, if that's an open, yeah. I have a question.
Okay.
I have an additional question because this was very interesting work, and you said that there has been a change in the number of climate zones or climate. Have you looked into? Have you plans to look into how the change of this climate classification will change with the climate change perspective? Is there something?
All right. Yeah. Yes. One purpose of made this actualization, the climate classification map, is exactly that topic. If that we have the first climate classification was in 1988. Now we have the updating of this map. So in a certain way, we can inference how is the variety of climate and the zone and the area that each climate change comparing these maps.
Well, that will be interesting. Have you looked more into what happened in the past? How this has changed in the past, except because from the previous version from 30 years ago? Sorry,
I can hear you.
Have you looked into the historical variations, except the one from the previous realization?
All right, well, I think it's have certain limitations, no? This map, and one the intention to make this map is to in the future we can analyze and we can more advance in the term or in the topic of climate change using this.
Okay.
Thank you, Oliver.
Thank you, Bill. Then I think we proceed, and the next thing on the agenda is actually to go to the posters. And we have 4 posters that is waiting for to be presented. And Peter Kayaba, are you here? Can you present your poster as a 3-slide presentation, preferably? Peter, can you hear me? I think no. No response. Peter Kayaba? I see you're unmuted, but we can't hear you. Okay, there might be some technical issues. Then I suggest that we just continue to the next poster presentation from Latvia. Viesturs, are you ready to give your presentation?
Yeah, no problem. I can quickly share the screen. It's 4 slides for me. I'm sorry.
Oh, okay.
I hope it's enough. It's not
You
too
offer
long.
me one. You offer me one for next time.
So, can you see my screen right now?
In a moment, I guess. Yes, there it is.
Okay. So, right. So, this work, more of an experiment that we did in Latvia in homogenization and change point detection in mean air temperature, monthly mean air temperature data. I will quickly show the reasoning for this research and also for our results, and maybe some questions that we had for discussion, as we are not homogenization experts, to say at least in Latvia, but we are very interested in this area and would like maybe ask for a little bit of advice. Yes, let's see how it goes. So, right, there is obviously a need to homogenize air temperature measurements among also other meteorological parameters in Latvia. And it comes also with the need of calculating the new climatic normals. And this is the reasoning that we tried homogenization in the first place. And we did the test with monthly mean air temperature data. Overall, we focused on 22 meteorological stations that are long-term climatic stations in Latvia from years 1949 to 2019. But here in this poster or / presentation, I will mainly focus on a case study of Ventspils meteorological station, which is over here. Hope you can see my cursor over here. Over here, I mean, and we performed multiple homogeneity tests. We started with Climatol, and afterwards we also checked like just statistical tests, like standard normal homogenization test, etc., to see where the breakpoints can be found. So how we did it, we obviously had hourly temperature measurements, which are recent, term temperature measurements either 3 times a day or 8 times a day, that are more historical, from 1949, aggregated into daily data, merged the temperature data series without too much of data processing, and checked for the breakpoints using R, using various packages like dataclim, change points, and etc. And here I will present the results of 3 tests: standard normal homogeneity test, voice hand, I hope I pronounce it right, range test, and petite test. So the results were quite interesting. That in multiple stations we found that the breakpoints were detected in the middle of the difference series, and what was very intriguing to us that there was no indication in the metadata that there should be any breakpoints. And we checked afterwards the different series of the closest also temperature measurement stations, and we checked if there's a trend in them. And the Mann-Kendall test showed that there is a significant trend in multiple of these stations. Like, for example, here in Ventspils, we can see that there's a trend between Pavelosa station, Stende, Maastricht station, and, well, stations that are close by. And we think that these breakpoints in the middle of the series can be attributed to this trend, and that these homogeneity tests show that there's a breakpoint somewhere in the middle, obviously, because it calculates this trend as it thinks of this trend as a slowing homogeneity, and it just chooses the middle point as a point where the biggest the difference in test statistics should occur. And we are not quite sure how to deal with this issue. As for example, where could this homogeneity should actually be fixed, and how and what would be the best test to really attribute for this local trend between different stations that we can see. And other than that, we also find similar results in Climatology, which is of course standard normal homogeneity test based. Here the trend is in a bit of a different location time-wise, but it still is near the middle of the stations. So yeah, that's a very short review, I guess, of what we did.
Okay, thank you, Versus. Do you have the possibility to upload your entire poster if you have a?
Oh yes. I actually have a Google Drive link. I will quickly add it over in the chat.
Yeah, perfect. And then I guess the discussion will start in the chat. Yes. Hopefully, either public or more private.
Yes, no problem. I would be really very happy to see any suggestions and maybe your thoughts if you have encountered similar problems. So yeah.
Yes.
Thank you for the attention.
Okay, then we continue to the next poster, and then maybe might come back to the first posters in the end. And Peter, I think now you are with us. So if you unmute, the spacebar should work, but we can't hear you. I see you are talking, but we can't hear you. Yeah. But the content is coming. You can check your microphone settings if there's something wrong with that. It's under the audio and video settings in the top panel. Sorry, Peter, but we still can't hear you. So there might be some problem with your microphone settings. But if you proceed to the next slide, we can read it, and then we can start ask questions in the chat.
Do you hear me, please?
Yeah, now we hear you.
Yeah, okay. Good afternoon, everyone. Do you hear me, please?
Yes, we hear you.
Yes. Okay. My presentation is about climate characteristic used in the design roadway with my colleague Katarina Mikulova, Maroš Turňa, and Jakub Ridzoň. The main aim was to update the norm for the design of roads and traffic areas loaded with non-rail traffic and climatic effects. The main output are 3 maps for the periodicity 0.1 and 0.15 and 0.25, and map with the average annual air temperature for the period 1968 to 2017 in Slovakia. Overview of the main step for final maps. First, data preparation, average daily air temperature for the period 1968 to 2017. Homogenized by program mesh version 3. Interpolation of climatic data in the GIS program. And last step was map processing of interpolated data layers by ArcGIS program. This is some results. Here is real data series with missing value. Can you see? And this one is verification files before homogenization and after homogenization. This is metadata for every station. This is interpolated data from GRASS program, and last picture is final map. Average temperature for period 1968 2017. The result presented in the paper show changes in the design value of the frost index for periodicity 0.1 and 0.15 and 0.25, and changes in average annual air temperature for period 1968 to 2017 in Slovakia. We used 93 meteorological stations for homogenization. Most important is that most inhomogeneities were caused by relocating the station or changing the observer or replacing the instrument. We calculate the frost index using the Pearson coefficient. The maps of average data temperature and frost index were interpolated with 3D method in GIS. The resulting map form the basis for updating the norm and are intended to adapt to the new climatic condition for the design of road and traffic areas burdened by non-rail traffic and climatic effects. All temperature regions have shifted slightly to the north. Thank you for your attention.
Thank you, Peter. Do you have a full poster that you could link to in the chat that is uploaded somewhere?
Yes, please.
So if you can just put the link in the chat, everybody can take a look. Are there any questions or comments immediately?
This is my poster.
Okay. Have you a possibility to make it available for all of us somewhere on a server somewhere?
Yes, of course.
Yeah, and then you can put the address in the chat or provide it to the organizers.
Okay.
Okay, thank you very much.
Okay, thanks.
Then we proceed to Elke. I think Peter has to stop his presentation first. then you can take over.
Hello, I'm trying to show the screen. So
Yes, we see that you are starting at least.
So this doesn't. I will try again. So now I can't share anything anymore.
Okay.
So it's gray. It's not possible. So maybe I have to log out and try again.
Okay,
So,
but while you're doing that, we can go to Peter Stepanek, and then you come back afterwards. Okay?
okay.
Yeah. So Peter, are you ready to give your presentation about your climate monitoring products for farmers? But you are also talking into silence. You have to activate your microphone somehow. And you have two different logins, so you have to activate your microphone in the correct one. There.
Okay, can you hear me now?
Yes, we can. But we have a severe feedback. So I think you should log out of one of your logins, Peter. Then it should work. But I see Elke, you are back.
Yes, I'm back.
Then we try Elke first, and then Peter can try to sort out his problems.
So is it working now this time?
Yeah, I see myself and a poster, so that's perfect.
So yes, I can start the video. So my name is Elke Rustemeyer. I'm working at the Global Precipitation Climatology Center, and we are collecting precipitation data on the global scale. So here I put all the stations we have collected, and these are the number of stations that we calculated the climatology from. And now there were a lot of questions, what influence the interpolation has. And so to really show it not theoretical, but also the values, we made a test data set. So this is a 9-year test data set. We used all the data we have during this time series and used several interpolation techniques. Here I wanted to show the sphere map, and also this is the difference between kriging and sphere map, so that you can really see the influence of the interpolation scheme and what the difference is. And the other question was always about the ETCCDI, so the extreme value indices. So I also calculated extreme value indices once on the stations, and then calculated the gridded data. And then on the other hand, we calculated the grids based on the precipitation, and then we calculated the indices. So this is the order of operation, calculating indices first or interpolating first. And here I want to show the results of the indices on the right hand that result in the order of operation. And this is that's what the poster is about. And you can see quite large differences when you look at the interpolation schemes. And for the extreme value indices, if it's here, this is the Rx, so it's the maximum value, one precipitation day. And I showed here the number of stations or time series we used to interpolate. So there is not really a difference on how many time series per grid are used to calculate the grid, which was really astonishing to me. I expected that differently. And the Rx is Rx1 is pretty similar on the order of operation, while if you look on other extreme value indices, the differences are quite high, as you can see in the bottom. So that was my short introduction to the poster. Thank you. So.
Thank you. Do you have the possibility to upload the poster in the chat somehow?
Yes, I will, but I think it will take 5 minutes or so. Then I will share the link.
Okay. Thank you.
Okay. Thank you.
And then we'll try Peter again. If you have can hear you now. I can't hear you, Peter. I see you, but I can't hear you. Maybe you should log out from that one as well and try to log in again. Ah.
Can you hear me now?
Now I hear you. Perfect. Then you can start sharing your screen.
I am sorry for the confusion, because on my PC I do not have camera, so I switched to my laptop. So I will start sharing. It connects for a long time. It just tries connecting, but nothing happens.
Okay.
Here, something. Okay,
yes,
so
there we have it.
Hopefully, yeah. So in my final talk, I will mention some products which are based on quality controlled and homogenized data, just to give some examples. And well, I think that the products I will present, so they are based on cooperation between my institution, which is Global Climate Change Institution, together with Mendel Agriculture University and Czech Hydrometeorological Institution. And we provide data which I will present free of charge to general public, state authorities, politicians, and to anybody. In the very beginning of all of this is quality controlled and homogenized data. And here I have to thank to organizers of this seminar, because it's thanks to them that this quality control and homogenization issues could be improved through the last more than 20 years through discussions within together and sharing knowledge. So I will mention very briefly what is in the beginning. So it's data quality control. We combine both temporal and spatial aspects and actually many methods together. Finally, we put the code into R code, so it can be shared very easily and applied in many places. Now we want to move from even daily data to quality control of hourly data, which is something that we test just now within our meteorological institution in the Czech Republic. As for homogenization, so from the very beginning, we combine several methods, several approaches. I try to put it into one software package, maybe Uncrim. There are some older methods, but still it's very usable for students, for instance, where they can try those approaches. And then there is Procrim DB software, which is able to process the whole climatological data sets. Already 15 years ago, we have our method finished, so we applied it on all the meteorological elements and daily data within Czech Republic. Actually, it was the time when tests within Kost-Homer were carried out on monthly data and only for temperature and precipitation. And about 10 years ago, we wrote a whole book, unfortunately only in Czech, some guidance on quality control and homogenization, and it's a whole book, so there are many examples. And as for the software, so we try to transform older one to some new platform, and I hope it will be possible to offer it to you next year. As for spatial interpolation, it is based on quality control data, homogenized data, and again, we developed own method for an interpolation. It is based on regression kriging, and we interpolated daily data from 1961 again for all meteorological elements. And maybe here I would have a remark. Tamas knows that mathematics is important. Yes, it is, but also some practical view insight into the problem is needed. And I think that these homogenization seminars are really very excellent platform for exchanging such mathematician and practical views and combine it together and get very nice results. So now I will finally move to applications where we apply this quality controlled and homogenized data. One of the application is in climate change for Central Europe. You know that climate models have big biases. For instance, in Czech Republic, they are about 1 degree centigrade colder, and they give you about 150 millimeters more precipitation. If you would study just climate change and compare nowadays and future climate, it would be nice, but well, for impact studies, it's needed to get it to absolute values, so it's where bias correction is needed. And now bias corrections comes, and it's very interesting from correction of inhomogeneities. It is based on the same assumptions. This is why I mention it here. Further, we use quality control and interpolation within forecasting for special needs in Czech Republic. We again run bias correction of numerical weather predictions models, interpolated values into half kilometer resolution, and thus make localized forecasts for any place within Czech Republic or in surrounding countries where they also use such products. Further, this is the last slide. I have to wait till it moves. It seems to freeze. So I will speak. Yeah, it's here. So it's drought monitoring. For drought, you need to calculate evapotranspiration, and for evapotranspiration, you need to know all meteorological elements. So it is placed when it comes in hand. What we prepared, I mean, quality controlled and homogenized series. Further, it uses some soil moisture models, and also here we used forecast. And as for drought monitoring, maybe I should mention that it combines not only ground measurements, but also satellite measurements. It's shown in this rightmost picture. And it uses also feedback from farmers, what is how it actually looks like in the fields. Further, climate change portals where we created and presented products based on Eurocordex regional climate models or global climate models, and products created to various fields of human fields like hydrology, agriculture, landscape management, ecology, and so on. And among our newest products belongs this activity where we monitor and try to forecast biotic and abiotic noxious factors for agriculture. So this was all together. It was just to show you where quality controlled and homogenized series can be applied, and maybe because I have the final talk, I would like to take advantage and give my special thanks to organizers of these seminars. It started more than 20 years ago. I remember that by the time, actually I am one of the last two Mohicans visiting the seminars from the very beginning. And I remember that in the first seminar, I created real slides, I mean, drawing it on, not virtually, but to be put on projectors. So time changed a lot from the time. And Buda and Pest cities, together Budapest, they were excellent places to visit and to discuss with all the colleagues everything, and really to move the things forward in big steps. So thank you nowadays organizers Monika Lakatosh, Andrea Kirchi, former ones like Zita Bihari Tamash, and especially Shandor Salai, who began everything in more than 20 years ago. So thank you.
Thank you, Peter, for starting the culture of this workshop, the seminar, and thank you for the presentation. I think we all can totally agree with your last statement that this organization of these workshops and seminars over so many years has really made this field